What we are going to be covering today is something called inverses. Now on the notes that you should have pulled up, what an inverse does is it's something that reverses another fraction. So think of the opposite. So let's say this is a function. This is the inverse. It does the opposite of the function. I'm going to be talking to you about some different ways that this happens. The very first thing that I'm going to be talking to you about is mathematically function notation with inverses. So if this is a function, f of x, this is in function notation, the inverse is the inverse of f of x. Anytime something is to the negative first, it's the inverse. If it has f parenthesis x, this is the normal function, and this is the inverse function. Now on your notes, I tell you this. If you take the inverse and you actually plug in your original function in place of the x, everything cancels out to get x. This is how you prove that a function and an inverse are truly a function and an inverse. If one's an inverse, one's a function, when you shove them together, you'll cancel out and you'll just get the variable that's left in there. So, let's do some things. I'm going to take f of x, and I'm going to say we have a normal function, 2x minus 1. The question is, find the inverse of x. Now, this is the way you do it. There's two steps to finding the inverse. Step one, you flip the x and y. That's the very first step. The second step is you solve back for the y. That's the second step. So what I'm going to do is this. I'm going to take this function and I'm going to rewrite it with y and x. Y equals 2x minus 1. Because tactically or conceptually, the f of x, that's your y value. Now, the first step, take my x and my y and boop, flip them. This becomes x equals 2y minus 1. This is my first step. I've done this step right here. Now I have to do this step, solve back for the y. So to isolate this y, I'm going to add 1 to move it over. 2y equals, if I add 1, x plus 1. And then I'm going to divide everything by 2. The reason why I'm doing this is because I'm solving back for my y. So I have y, this cancels out, equals x over 2 is 1/2 x plus 1 over 2. Now if I rewrite this as in function notation, because it wasn't originally y, it was f of x. So if my original function is f of x equals 2x minus 1, the inverse, the other function that does the opposite of this is 1/2 x plus 1/2. This is my original function. This is my inverse. Look at this rule that I wrote back here. What I said was, cover this up, and I'm going to say, look at this rule. If I take my original function and I plug, and I have my inverse, if I know my original function and my inverse, and with the equation of my inverse, I plug in my original function in place of that x, do all the math, I'm going to get x as an answer. Or this could be flipped around. This could also mean f of inverse of f of x. You could actually plug in your inverse in place of the function for your x. No matter how you do it, you will get x as an answer. So if that doesn't make sense to you, let's come back to these. What I'm going to do is I'm going to plug one of these in place of the other x. Let's just follow this rule. I'm going to take the inverse and I'm going to plug in 2x minus 1 in place of here. Watch what happens. So I have my original function, 1/2 x. Instead of x, look, instead of x, I'm plugging in the function. I'm plugging in this function, 2x minus 1. I'm plugging this in place of x, plus 1/2. The reason why I'm doing that is because this is how you prove that these two are true inverses. And when I do the math, I should be left with x. Now let's look. Half of 2x is x, if I distribute this. Half of 2x is x. 1/2 times -1 is -1/2 plus 1/2. These two cancel out to get x. That means they are inverses. And then if I do it the opposite way, if I were to go take my other function, 1/2 of, instead of x, I'm going to plug, oh wait, that's what I did before, I'm sorry. Let's do the other function. Let's do 2 times, instead of x, I'm going to go 1/2 x plus 1/2 minus 1. I should get this answer. So what I am doing is I'm doing the other way now. I'm taking my original function and plugging my inverse into there. Watch. 2 times 1/2 x is just x. 2 times 1/2, half of 2 is +1 with that -1. Boom. They cancel out and I get x. That's how you prove that it's an inverse. Okay, let's look at the second example question. Second example question says, let's take 2 more functions. F of x equals square root of x plus 2 and then minus 3. And now it wants me to find the inverse of f of x. Let's pause the video and see if you can flip the x and y and solve back for the y. Okay, let's see how you did. I want to find the inverse. So what I'm going to do is I'm going to rewrite this equation. Y equals root x plus 2 minus 3. Now I'm going to flip my x and my y. I'm going to take these two and boop, flip them. X equals root y plus 2 minus 3. All right, I got to solve back for my y now. There's only 3 steps. First step is add 3. X plus 3 equals y plus 2. Now, how do I get rid of this? Well, square it. But I have to square this also. So I'm going to have, if I square the square root, I have y plus 2 equals the quantity of x plus 3 squared. It's not x squared plus 9. It's the quantity of that, which is going to be x squared plus 6x plus 9, but you don't need to multiply that out. Anyways, move this over, minus 2. And now the inverse is this, because my y is all by itself. Step number 1, I flip the x on my y. Step number 2, I solve back for the y. So the inverse is x plus 3 squared minus 2. Okay, now let's do this. Let's see if they are true inverses of each other. So what I'm going to do is I'm going to take this x and plug it into this x and see if I get x as an answer. All right, so I have, instead of x, I'm going to put the parenthesis. I have x plus 2 square rooted, then plus 3 squared minus 2. And this should give me x as an answer. Well, let's check it out. Now, what this is going to be is we're going to have root x plus 2 plus 3 twice. Root x plus 2 plus 3. Oh, wait, hold on. Sorry. This, I forgot about this minus 3. Sorry, guys. I was like, wait, something's not working out here. Hold on a second. Something's not working out. I'm going to rewrite this right here. I was like, wait, hold on a second. Equals the original thing, x plus 2 minus 3. And my inverse of f of x is quantity of x plus 3 squared minus 2. Okay, now what I'm going to do is I'm going to take this and I'm going to plug it into here. So I have I'm going to take this whole thing, x plus 2 minus 3, and I'm going to plug it into here. Boop! And then so I have, and then plus 3 squared minus 2. I took this whole thing, I'm plugging it into this x. I'm going to do the math now to get an answer. All right, so now look, negative 3, positive 3, cancel out. Now I have x plus 2 squared minus 2. This squared cancels out the root to give me x plus 2 minus 2 to give me x. So those are, in fact, inverses of each other. Okay, see if you can prove that this, the next question is telling you 2 over x minus 1. It tells you to prove that this is a function and prove that 2 over x plus 1 is the inverse of this function. The way you prove it is you take one of these and you plug it into your other x. So I'm going to do this, 2 over, I'm going to plug this whole thing in place of this x, 2 over x plus 1 minus 1. Simplify. Negative 1, positive 1, cancel out. And I get 2 over x, which is going to be 2 over 1 times the reciprocal, x over 2. That's simplified to this. Boop, to get x as an answer. There, I just proved that those are, in fact, the inverses of each other. Okay. Now the next thing is graphing. Graphing is the same concept. You take the x and the y and you flip them. Take the x, take the y, and you flip it. Now remember that concept because I'm going to be talking to you about how to graph these. And it might seem a little confusing at first, but it's really not that bad. Okay. Okay, now on the second, starting off on the second thing on the notes. It wants you to graph, find the inverse of y equals 1/2 x plus 2. Pause the video and see if you can find the inverse of y equals 1/2 x plus 2. Okay, if you did it, paused it and did it, it should have been y equals, I'm going to do this real quick, flip the x into y, so I'll back for the 2, so x minus 2 times 2 is 2x. X minus 2 times 2, 2x minus 4. Okay, there's, this is the inverse, and this is the regular function. Now watch, I'm going to graph this on 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And you'll see why I'm doing this really detailed, because I don't normally do things detailed, but you'll see why I'm doing it to explain this concept. I'm going to graph this, go up 2 and then up 1 over 1, 2, up 1 over 1, 2. Something like that. All right. And then this, I'm going to go down for 1, 2, 3, 4, and then go up 2 over 1, up 1, 2 over 1, up 1, 2 over 1. Then if I were to continue this, I don't know, it would look something like this. Okay, now look. There's a line called the y equals x line. And the y equals x line is this. 1, 2, 3, 4. This is the y equals x line. The reason why that's important is because look at the second page of your notes. The second page of your notes says inverses are reflections over the y equals x line. Look at these two coordinates, for example. If I were to flip this, this coordinate is 2, 0. Remember, when you take the inverse, you flip them. So this coordinate, boom, becomes 0, 2. Look at this coordinate right here. This is 0, negative 4. If I take it and I flip it over the y equals x line, it's actually a coordinate of negative 4, comma 0. They are flipped. So when you are graphing conceptually, the whole graph and its inverse is if you were to take the y equals x line and then just do this. Boop, flip it. Look at the example that I give you on quadratics. I tell you the quadratic is, well, I say, here's your quadratic, looks like something like this. And then I give you the inverse, and here's the y equals, this is up 2, I'm sorry, this is up 1, 2, boop. And then what's this coordinate is 0, 2. So on the inverse of this coordinate would be 2, comma 0 right here. And this, if I were to take it and reflect it over the y equals x line, it would look something like this. Inverses are just flips on the graph. That's all they are. On the x, y equals x line, whatever the graph is just a flip. The very last thing is I give you like a graph, it looks something like this. And this coordinate right here on the last graph is negative 3, comma 0. So this becomes 0, comma negative 3. This coordinate right here is like negative 3, comma negative 1. This becomes the new one. It becomes negative 1, negative 3. And then boop, boop. I mean, it's more or less, look, it's just a flip. This point is the same distance from here to here as it is from here to here. This from here to here is the same length from here to here. They are just inverses of each other.